Okay, we're going to talk a lot about more about a three-equation system in the near future here, but for right now, let me just talk about, well, this system here. Yeah, you've got three equations, and typically when you have three equations, you're going to have three variables, x, y, and z is our preference, I guess you might say, for the variables. So yeah, I've got three equations and three unknowns, three variables. And so, of course, it's going to take three parts to make a solution. We need an x and a y and a z. And so, in this particular case, x, y, z is a solution, or any case, x, y, z is a solution. Guess what? To be a solution, what does it have to do? It's got to work in all three, right? So x, y, z is a solution if it works in all three, satisfies all three. Okay, and so is 1, -1, 2 a solution to this system? Well, if we've got because it takes a little bit of work to get these solved, and that's what we'll talk about later on. But if we've got a triple here, order triple we call it, to check, just check it in all three. So just plug that in. Of course, this is the x, that's the y, and the z. It's still ordered, that alphabetical order, x, y, and z, in that order. So yeah, so we just check to see if it works in all three, if we've got something to check. All right, so 1, and then -1 for y, and then 2 for z. Does that equal 9? If it doesn't, then you can say no, but if it does, we'll check the other ones. Yeah, that's going to work, isn't it? So what about the other one? -1 plus 3 times, whoops, yeah, -1 plus 2, does that equal 4? The second equation, so it works in the first one, but I'm seeing it not working in the second one, aren't you?
Or -2.
Yeah, so that would be -2 equals -4. So to be a solution, it has to work in all three, and I don't have another one to try here. So, but in the homework, I know they have you try several on one system. But anyway, just wanted to mention that to you, and we'll talk more about these three equation systems in the very near future. All right, but let's go to another matter, that is inequalities. And graphing, first of all, we'll graph some inequalities. Review that a little bit. Yeah, when we throw in an inequality to the mix here, like x plus 2y is less than or equal to 4, that adds a lot to this as far as solutions go. However, we do have the equal to part here, and so the first thing you do on these inequalities when you're graphing them is you first graph the equals to part, whatever that may be. In this case, we got x plus 2y equals 4, so I graph that first. And that, in this case, is just a line, right? the other one we'll do, besides the line, will be a parabola. But it could be any sort of shape, but we'll narrow it down to lines and parabolas, I think, for our work. But it could be, anything else that we can graph. But in this particular case, it's a line. And, however you want to graph that line, you can put it in y equals mx plus b form. Usually when they're like these, I get a couple of points in a table or something like that. You can do x equals 0, x equals 1, x equals 2, whatever your choice. These, what I like to do are the intercepts. The x is 0 and then the y is 0. They seem to be pretty easy ones to get. So if x is 0, we got 2y equals 4. So y would be 2. You can see it worked out there. And then if the y is 0, we'll have x equals 4. And so that gives us two points there to graph. So we graph that first. 0, 2, and 4, 0. So this is just one way to do that line. However you want to, I don't care. Just get the line graphed. So here it is. Now, that's the equal to part. I still have x plus 2y is less than or equal to 4. Well, what the inequality part adds to this mix is, usually what it adds to it is one side or the other, all the points on one side or the other of this graph, the line, is going to satisfy this inequality. And so what the inequality adds is, what I usually say is it adds some shading to the graph. Okay, we got to figure out, well, do I need to shade below the line or above the line? And you can't necessarily go off less than is below the line, greater than is above the line. What I like to do to determine the shading is just check a point on one side or the other of the line. Now, it can't be on the line. That's the only restriction, I guess. So 0, 0 is usually a good one to check. So we're going to check 0, 0 in the inequality and see if it works. Okay? So if I plug in 0, 0, I've got 0 plus 2 times 0, is that less than or equal to 4? 0 is less than or equal to 4? That's true. Okay? So 0, 0 works, and so I want to shade the side that has 0, 0 in it. With me there? Mm-hmm. So here's 0, 0. It works, so I would shade. That would mean all the other points with it on the same side work. If 0, 0 didn't work, I'd go to the other side, you see. Okay?
I have a question.
Question.
If the graph is less than or equal to 4, does that mean that automatically you could shade anything that is less than 4 on the x value line from that side?
Not necessarily, no. You have to check. That's what I'm saying. You have to check. It doesn't necessarily mean below the line or above the line. Sometimes it can go the other way. So I would check that point. Okay. Now, a couple other quick little notes here. If I said graph x plus 2y is less than 4 without the equal to part there, so it's the same line we're talking about, same x and the same y intercept, or same 2 points I got. However, the equal to part is not a part of that inequality. And so what that means, the equal to part of this graph over here was the line itself. And so, technically speaking, the line itself is not a part of this graph. However, it is a boundary. And so we need it. Yeah, so we would, typically what you see is dotted in instead of a solid line. And so the equal to part is not there, but we still need it as a boundary. It's still all the points on this side, because 0, 0 would still work there, right? 0 would be still less than 4. So everything's the same except it's just a dotted line. Okay? And so the idea is the same for other types of graphs. If I have y is less than or equal to x squared minus 9. Well, you first of all just graph the y equals x squared minus 9 graph. What is that? What shape is that?
Parabola.
It's a parabola, yeah. Parabola, and these are pretty basic ones. You don't have to necessarily go into all the fine details we did on some other quadratics, but yeah, it is a parabola, and in this case it's shifted, it opens up, I guess you should say that, and it's shifted down 9. So noticing those things can help us kind of get a visual there. Now what I probably would recommend to get width and all that good stuff is probably do, you know, at least a couple of points. This is just shifted down 9. These three should probably will suffice. If x is -1, then we would have y is -1 squared minus 9. So that's 1 minus 9, that's -8. Y is 0, we would have x is 0, y is -9, and then x is 1, we'd also have -8. And so just a couple of points to give you kind of the width of the things instead of making it too wide or too narrow. That's what I'm talking about. So 0, -9, and -1, and +1, -8. All right. Now, like we said, we could sometimes just dot that in. In this case, do I want a dotted or a solid?
Solid.
Solid, yeah. You want a solid if you got the equal to part, right, in your inequality. Right. Yeah. So you want a solid line if you have the equal to part in the inequality, and dotted if not, okay? All right. So this is a solid one. All right, but we're not quite done here.
Check our 0, 0.
Yeah, because we do have an inequality, so there's some shading involved. And so we would need to ask ourselves, well, which part do I shade? Yeah, and again, check a point not on the line, or in this case, the parabola. 0, 0. Does 0, 0 work? And we're checking it in the inequality. Y is less than or equal to x squared minus 9. So that 0 is less than or equal to 0 squared minus 9. Yeah.
Outside.
That's not true, is it? That's false. So 0, 0 doesn't work. So the point 0, 0 is inside the parabola, and so in this case, yeah, we would go the outside. So yeah, it may not be what you think it is, so that's why you got to check those out. All right, just a couple others here. We have x is less than 2. X is less than 2. Well, the line part of this, we can first of all think about x equals 2. What do we got there?
X is 2.
X is 2. It's a vertical line, right? Yeah, so you got a vertical line at x is 2. Now, Dotted or solid?
Dotted.
Dotted line, you don't have the equal two parts, so it's dotted. Zero, zero, would it work?
Yes.
Yeah, 0, for 0, 0, all we have is x is 0, so 0 is less than 2. So yeah, 0, 0 does work, so it would be this side of that line. Okay, what about y greater than -3? Well, we first of all do y equals -3, and so we're talking about the other variety of these special lines, I guess you call them. That's a horizontal line, isn't it? The y is always -3, and so we're talking horizontal line there through -3. And again, it's strictly greater than, no equal to parts, so it's a dotted horizontal line. And again, the shading is the other part to this. Which side?
Top.
Yeah, 0, 0 would work. 0 is greater than -3 or 0, 0 check. The y is 0, and so that'd be 0. Yeah, that's true. So we would shade the top. Okay. Any thoughts or concerns on that? All right. So now we know a little bit about those. We're in the systems mode here. So what about systems of inequalities? So what about systems of inequalities? Well, let's talk about this. One variety they'll have us look at is this. So we've got 3 inequalities in a group. So we need to talk about, what it all means. Well, yeah. So each one of these is a graph with shading, right? If we graph them separately. So when we put them in together with in the context of a system, guess what that means? The solutions to this system are going to be where all 3 are satisfied, where they all overlap, okay? So solutions to a system of inequalities is just where they all overlap. So let's think about this. First of all, this top one, x minus 2y is less than 5, okay? So that would mean, first of all, graph the line, right? Like I said, I usually like the x and the y-intercept. X is 0, y is 0, that's set up. But do it however you want. All right, if x is 0, I got what? Y is -5/2. -2.5. If y is 0, I would have a little easier. That's 0, so that would be x is 5. So just 2 points, get a couple points, and you got it. So 0, -2.5, and then 5, 0. And we know, since we don't have the equal to part, that is this dotted line. Do that. Okay. Now, as far as the shading goes, what do we see happening there? Well, check 0, 0, right? 0 minus 2 times 0, is that less than 5? 0 is less than 5, isn't it? That's true. So 0, 0 works, so I would shade the side with 0, 0. I'm not going to mark it totally here, because I'm ultimately just going to shade where it's overlapping with the others, so just kind of give myself an indication. I need to shade the side with 0, 0, so I'm shading above the line. Okay, now the others, the x is greater than or equal to -4. Well, that's our vertical line we're shading. So that's a vertical line through -4. And it's solid, right? Which side? 0, 0 would work, so I would shade to the right. And then last but not least, the y is less than or equal to 3. That's our horizontal line. Y equals 3. And it's solid because you got the equal to part. 0, 0 would work again, so that's below the line as well. Okay. So I'm looking for where all these overlap, and sometimes it's probably what you would think. In this case, which pieces am I talking about?
Triangle.
Yeah, it's a triangle inside here because it's above this line, below the horizontal to the right here. So yeah, it's everything inside here. So it's all this. You want to make sure that's really the only shading to be done as far as the solution to the system. It is the triangular part inside there. Okay? With me? All right. Anything further on that? Look okay? With that? Good with that? All right. What about y less than or equal to x, and then y plus x squared greater than or equal to -6? Shade that system there. Solutions. Well, sometimes they do give us these lines in a form. We can use the y equals mx plus b. Y equals x. If we graph that line, it's the 45-degree line, you can call it that, but it's 1, 1, 0, 0, 1, 1, 2, 2, all sorts of easy little points there. And it's a solid one, right? Got the equal to part. Now the first point on this is, as far as shading this one, the 0, 0 is not a good one to check. Why not?
Because it's
right
the
on the
center.
line.
It's on the line, yeah. And so go to a different point, it doesn't matter. Just some point not on the line. 0, 0 is on the line, so we can't use it. So what about 1, 0? That's not on the line, so we can check it. So 1, 0, x is 1, y is 0.
Oh. No, that's true.
It's true, isn't it? So 1, 0 would work, so that's here below the line. So I'll just indicate below there. All right. Now what about this one? Second one, Well, we've got y plus x squared equals -6 would be the thing to graph. What would I probably do there to help me out? Move that over, make it y equals -x squared minus 6, subtract the x squared, and then I can see, yeah, that's a parabola that opens down and down 6. Because the -6 there. So I kind of have a visual parabola down, opens down and down 6. All right. And get a couple of points to get the width right, if you will. If x is -1, the y would be, well, square the -1, that's 1, but then I negate it, so it's actually -1 minus 6, so that's -7. And then x is 0, we have -6, and then y is 1, x is 1, we'd also have -7 if I'm looking at the same thing there. So anyway, that gives us some good points to get. So 0, -6, and -1, -7, and there's 1. Like that, so. And it's solid, so. Looks like that, and then the shading, okay, for that. That one, I could check 0, 0 on that. 0 plus 0 squared, is that greater than -6? Yes, it is. So 0, 0 works. So I'd shade the side with 0, 0, and so that's, again, outside the parabola. So what would I shade?
Above it.
Yeah, below the line, but above the parabola, right? So it's everything in this range here. Don't go inside that parabola, because it's below the line, but it's not above the parabola. Okay? This good? Anything more on that? Okay? All right?